Welcome back. Today we will solve 199 of LeetCode binary tree right side view. So let's just look at the example. It will become clear. We don't actually need to read the question. So it's very simple. They will give you the tree and they want you to send as output the most right view. For example, in each level, for example in first level, in this tree first level, the most right node is 1. So we have 1 in the answer, and also in the second level the most right node is 3. So we have 3 here, and in the third level the most right node is 4. So we have 4 here. So the answer is 1 3 4. This is the output and this is the answer. So to solve this question you will need to know about how does a binary tree work. You need to basically know about binary tree, you need to know about stack, you need to know about queue, and you will need to know about level order traversal. You have to basically you have to have a good understanding of these four concepts. So how will we solve this question? Let me show you another example. We cannot think that you cannot think that we will just keep on going right. If we don't find right, we will go left. That's not going to work. Why? Look at this example. In the second example they gave, the root is 1. Okay, so you might say, okay, root, we have the root is the most right node, so we have 1. Then from this we have the left node, we have the right node, which is 3. So we just keep on going on the right side. So here we have 3 on the right side. So then we will have 3 in the answer as well, because as you can see this is also the most right node. And then if you just go on one side, you will see that you will run into trouble. Why? Because 3 doesn't have right node, 3 doesn't have left node, so you get stuck that way. That's why you have to keep track of the whole tree together, because if the 3 doesn't have left child right side, but on the other side, on the left side of the node, you have left child of 2, which is 4, and then you have left child of 4, which is 5. So in the answer we will have to, with 1 and 3 we will also have to include 4 and 5, because even though they are on the left side, if we see from the right, we'll see them on the most right side. I guess it makes sense. So this is something you have to keep on mind. Now how will we solve this question? It's actually not that difficult. You basically have to take a queue. You will have to take a queue, and you will have to level order traversal. You will have to go through each level. For example, level 1, you will just add each level, and you will keep track of every level separately by using a for loop. I will show you how to do that. And after that, in each level you have to put all the value of a level into a queue, in a stack. For example, in the let's say we are on the second level. Let's say we are on the second level. So in the second level we are traversing from left to right. So in the left we have 2, and then we have 3. So we have 3. So when we and then we'll just take the top value of the stack. Why? Because in the top we will always have the most right node of each level. So we'll just take this 3 and we'll add this with the answer. We'll just push back this in the answer. Okay, I guess it makes sense. So I'll just show you the code now. It's not that difficult. First of all, what do we have to do? The code, yeah, it's all working perfectly. Vector, of course. For example, first of all, let's just take the answer. Like, the answer is the answer we have to return is integer of vector, right? So let's just take that, and then first let's just deal with the edge case, which is if the root is empty. So if not root, return answer. Yeah, so we have dealt with the okay, wait. Yeah, I guess, yeah, we dealt with the edge case, and then we just have to take a STLQ. Of course, we have to take the tree node as input here. Let's just call this queue. Yeah, and then we just basically have to push the root on the key root on this queue, and then let's just we have to go through the whole queue. Queue dot, okay, empty. We'll have to go through the queue as long as it's not empty. So what's next? Yeah, basically we'll have to take another node to keep track. Let's call it P for parent, and then yeah, we just have to front of the queue. We'll just have to take the top value or front value of the queue, and then we'll just simply pop the queue. So then we'll just check if we have right or left child of the P. So if P have left, then we'll just add this on the queue. Push if P have right, then we'll just push the right as well. Okay, did I forget anything? We'll need something, and what is that? Okay, wait, we'll need a for loop, right? Yeah, we'll need a for loop. Okay, integer, let's say we'll have to take a for loop, and we'll run the for loop according to the size of the queue. So size of the queue, and then for integer I equals to 0, I is less than size, and I plus plus, and all of this is gonna go inside here. Oh my lord, what am I doing? Yeah, now something is we'll have to obviously make a stack. So let's just call the stl stack, and of course it will have integer as input, and let's just call it most right. Okay, and then we'll have to keep on adding the value of P in the most right push, the value of the node. Okay, and after traversing through each level, we'll just pop the top value of the stack. Okay, so we'll just add that in the answer. P, no, sorry, most right. Okay, most right top. Okay, for stack we use top, and for queue we use front. Okay, whatever. And then you just have to return the answer. So let's just run it and see. As you can see, all the test case passed, so it's going to be accepted. Yeah, so you can see that it worked perfectly, and it's like you cannot do it in any other way. You have to go through the, like I told you, you have to go through the whole you have to like traverse through the whole tree. You cannot just take the right value. So since you have to traverse through the whole tree, the time complexity is always going to be just O of n. I hope it makes sense.